Hey guys, so I got a question from a couple people when they were watching those YouTube videos, and their questions were, what white dwarf was the closest, and how do we get there? Because we talked about as our sun starts to, in a billion years, get to the point where it's going to make Earth pretty uninhabitable, but we're going to need to find someplace else to live. And we found out that in the solar system, uh, white dwarfs and red dwarfs are pretty good places to live. White dwarfs probably being better. So again, a white dwarf typically comes from a main sequence star that goes through its red giant phase. It blows up, and what we get left off with is a very, very dense star that's still putting off quite a bit of heat, and it'll do that for a very long time. All right, so I found a handful of white dwarfs in the Milky Way that are kind of close. We're talking 8.5 light years all the way to 18 light years, which right now is pretty much way too far away. But if we look at some of the ways that we can get there, it could be a possibility. So we're going to look at these white dwarfs, see if there's something that we could actually live around. So first, let's talk about what a light year is. The ones that I listed are relatively close in terms of light years, but the technology that we have just doesn't get us there very quickly. So one light year is about 6 trillion miles, and the fastest probe that we have right now would probably take around 4,500 years to travel just one light year. And we uh, looked on that other slide, and it had 8 light years to that closest one. So our probes, based on the propulsion we have now, way too long to get there. So we got a couple solutions. We could do something called nuclear propulsion. We could have a spaceship that is driven by nuclear power, possibly. There's some estimates that they could reach 36,000 kilometers per second. So we could travel a light year per decade, which is awesome. We're far away from that, but that's a possibility. The other possibility, if we can't get stuff to go that fast, would be to have generation ships going out in these giant ships with the knowledge that it's going to take thousands of years to get there. So we're going to have lots of generations grow up in those ships. So these would be absolutely gigantic things that could have tens of thousands of people on there, and they would live normal lives and have kids, and their kids would have kids, and so on. And eventually, uh, many generations from when they set off, they could possibly be at where they want to go. So here's an artist rendition of what one of those would look like. Look very similar to to a city on Earth, just not on a planet. So we'll get back to this one a little bit later after we decide on a star that we want to be around. And it'll be a really huge undertaking to build a generation ship. There's still obviously a lot of technology that we'd have to develop to do that. We'll get back to that later. So our first contestant was the one that's closest to us, Sirius B, 8.5 light years away. Um, it is part of a two-star system. Sirius A is the brightest star in Earth's sky. So if you look out at night, if you see a really bright star, that's Sirius. So Sirius B is a white dwarf. It is in a two-star system. Um, very hot. It's probably only 250 million years old or so. So it hasn't been a white dwarf stage for very long, which has some problems associated with it. Um, Part of a two-star system, which possibly could be an issue. So instead of just having one sun on your horizon, you would have two. They are pretty far away, but that could be a possibility. It is relatively young. We just saw that it was only 250 some million years old in the white dwarf stage. Um, don't know if there's any planets around it. We haven't really detected any. It doesn't mean that they're not there. But the problem is, if we when we go through that red giant phase and we have that star explode, typically, if there's any planets there, we're going to fry them. So something that's this young, the planets around it probably not somewhere that we're going to be able to have an atmosphere to survive on. So this one, it's close, but maybe not a good choice. Second one, not even gonna try to pronounce that one, but here's our second one. Um, it is also a companion star. Uh, it is so it's a part of a two-star system. Also, it is a lot less bright. The problems with this one, it is closer to its companion star than Sirius. We're still talking about pretty big distances, so those stars are as far as the Sun and Saturn are, so pretty big uh, distances based on how we perceive distance, but they are still relatively pretty close. So don't know what would happen with two stars in the same system that are that close together. Might not be a good choice on that one. As far as we know, there's no known planets around that one, but again, it's pretty hard to detect planets, and we're just kind of starting to do that over the last decade or so. So maybe there is. All right, third one that we had, Van Manen star, I guess. It is a solo star. So the first two that we talked about were double stars. This one is a lonely star, and it is old. Um, it's cooler. It's only about 400 degrees Kelvin hotter than our sun. So pretty much what that tells us, if there were planets around it, or if we wanted to be around it, we would have to be relatively close because it is small and it is not as hot as most of the white dwarfs. Um, the time period that it would take for a white dwarf to cool off tells us that this guy is probably 9 billion years old. That's that's double the age of our the solar system that we're in. This one looks like it could be a good candidate. So this is the first one that I've actually seen that actually gives me a little bit of hope that this could be a possibility. It's solitary, so you don't have to worry about some weird things going on with a second star in the system. It's old. It's in its white dwarf stage. It's twice as old as our solar system, so that tells us that maybe there's been, even after it went through its red giant phase and it blew off some of the atmospheres if there were planets by it, there's been a long time for those maybe to redevelop. And the third thing about this one has a circumstellar disk. So, circumstellar disk, it's a ring shaped accumulation of matter, so it's going to have gas, dust, asteroids, maybe tiny little planets, collision fragments, all that kind of stuff. Um, So around mature stars, they indicate that planetesimal formation has taken place, and around white dwarfs, they indicate that planetary material survived the whole of stellar evolution. So we might have planets, parts of planets that survived that red giant phase, and they possibly have enough time to redevelop an atmosphere, or maybe possibly come back together as planets. Maybe they're close enough that they could be useful. So we've got three really good points on this one. Solitary, it's old, and it definitely has potential for having planets there. As far as what I've read about it, I don't know if they've detected any planets around it or any that are even close enough to sustain life, but we actually have a possibility there. Next one, GJ440. I didn't even give this one a name. It's a solo star, which I guess is beneficial for us. Um, Probably in the Middle Age, about 3 billion years. So, and that is still pretty old. Biggest problem with this one is we don't really know a whole lot about it. Could be good, could be bad. Don't really know. So we can kind of move that one down the list a little bit. Our next one, 40 Eridani b. So it's a member of a triple star system. So the first two we looked at were double star systems. This was actually a triple star system. This one has only been a white dwarf for about 1 billion years. And it's not really from a very big star. The problems: one of the stars, 40 Eridani c, it tends to produce massive blasts of X-rays. So if a planet was close enough in that area of Eridani c, they could get blasted with lots of X-rays, which is not good for the atmosphere or the living beings that would be on that planet. So this could be an issue here. So possibility, but probably not high on our list. Benefits of this one though: a planet has been found around 40 Eridani A. So we definitely know that around one of these white dwarfs in this system, there's a planet, which is something we haven't found on our other ones yet. And our last one, it has a red dwarf and a white dwarf in the system, which could be beneficial. But we really don't know much about this one, so we can kind of get this one off our list too. So definitely, obviously, the winner is going to be our third one, Van Manen star. Seems to be the safest bet. We don't really know if it has planets there, but it has a possibility, and it just seems from our data that we've got, it's probably our best bet. So it's old, potential for planets, and there's no nearby other stars, which might cause some weird gravitational anomalies. Runner-up is not even one that was on the list because we were talking about white dwarfs, but I found one that could possibly be a runner-up, Proxima Centauri. It's a red dwarf, which has some issues because they're very variable. They can be a lot more violent than white dwarfs, so potential problems with that. But it's only 4.2 light years away. So if we were using nuclear propulsion, we could possibly get there in half a century, potentially. That's pretty cool. You could actually get on a ship and make it there in a lifetime, potentially. See your new home. It contains a planet in the habitable zone. So habitable zone is a place that's far enough from a star that it can still have liquid water on the surface. We know that this one has a huge planet that is within the habitable zone. Computer models similar to those used to study climate change on Earth, researchers have found that under a wide range of conditions, if the planet Proxima Centauri b can sustain enormous areas of liquid water on its surface, potentially raising its prospects for harboring living organisms. So has a planet that's in the habitable zone. It's a big one, and it possibly has a liquid water on it. This is an artist rendition of what they think it would look like. Look, the atmosphere would be a little bit different color because it is a red dwarf. And again, red dwarfs have lots of problems associated with them. Their energy output is variable, so we could have times where it's really, really hot and times where it's really, really cold. So that might not be an option. So back to if we can't figure out nuclear propulsion to get there quickly, our other option would be our generation ship. If we wanted to build a generation ship, we would probably want to build this outside of Earth. Best bet would be to make a base on Mars or the Moon, and we could build it there. We could possibly harvest materials from asteroids or comets rather than try to dig it up on Earth and shoot it out into space and try to build it like that. That's very, very expensive. So possibly if we could figure out how we can harvest materials from asteroids or comets, we can build most of it outside of Earth. And this would give us the possibility to learn how to live outside of Earth if we were on these extraterrestrial colonies. So generation ship, in my opinion, would probably be the best way to do this. From the options that we had, I don't know if any of them seem like I would put a big bet on them. I think our best option might be some of the moons around Jupiter or Saturn. They're far enough away from the sun that when it goes through its red giant phase, we could still possibly be in a place where we could survive there. But there's the answer to your question of what the closest white dwarf and how do we get there. So if you guys like these questions, if you like the answers to the questions, you can let me know, and we can discuss some other questions also. And just for some extra credit, your code for this video that you'll be able to put into a Canvas assignment, the code is 413. So there's our answer to this, at least as much of an answer as I can give you. I'm sure some astronomer could give you a better answer. But I'll talk to you guys later.